Welcome to the Vienna Data Science Group Meetup. So this is already the second one this year. My name is Florian Türk and I will do the moderation for you tonight. So what brought you here is probably the tension currently going on worldwide with generative AI and who the big players are. And probably you also feel like Europe and especially Austria is kind of left behind by the big players. So we thought we would make like a meetup which is dedicated to more local solutions and local approaches to get know-how and to build solutions. So yeah, we are very happy that we are actually here for this meetup. So that Vienna Scientific Cluster is hosting us here, and that EuroCC has helped us organize this event. Because I mean, they are the ones who build the infrastructure, have the infrastructure, which can really sort of compete with other infrastructure around the world. But before we start with the real talks, it's important to do some housekeeping. So we'll do a short introduction about what the Vienna Data Science Group is, what we do, and why you should care. Then there are the main talks, and then we have some other small topics. So for instance, the open mic session. This is basically somebody from you coming on stage and having the possibility to talk for 1 minute about any topic, be it job positioning, being some kind of promotion that you want to do. I think there are now 3 slides, as far as I know. Feel free to still apply some. The link is you can find in the meetup description. So go ahead and tell us something about you. We also have a raffle again. So we have one book here. We'll come to this later, but we'll raffle this away at the end of the event. And then there's socializing and with food and drinks as usual. In addition to that, the Vienna Scientific Cluster also provides some guided tours through the infrastructure. So at the end of all of this, of the formal part, there will be groups. So for 15 people at one part, every 5 minutes, so we can get everybody through. And in parallel, there's the socializing part. Yeah, so who are we? Who is the Vienna Data Science Group? We are an association and fine. We are non-profit. And we have the mission to build up knowledge and distribute it among data experts, data scientists, data enthusiasts. You know, whoever wants to work with data is welcome here to share ideas and learn something. We already have around 5,000 members at Meetup, so we are pretty large. We have, I'm not sure which one exactly, but we have more than 100 meetups. So it's the mixture of different formats that we provide. But we do this very regularly, as most of you probably already know. Yeah, and we also have a board. So unfortunately, there are not too many here today because of sickness and other reasons, but Sultan here is with me and myself. So if you have any question regarding the Vienna Data Science Group, then feel free to approach us afterwards, and we will help you find your way through it. That brings me to the next point. So what do we do? So we try to build up knowledge, try to distribute it. So we do this mainly via the meetups that you see here. So we have approximately once per month, and the next one in February is already pretty finished and organized, and this time it's a hackathon. So if you feel like you want to learn something and work on a really nice use case with real data, which is for the energy efficiency with synthetic data, you feel you have like one spare weekend, then please come by. We'll be there. We will be mentoring. There will be, of course, also prizes. So tell anybody that you know that who might be interested. There are still open slots available. The other part is the book. So members of the community, we put them together to write a bigger book. So everybody who has their own expertise wrote according chapter. You can buy this actually on Amazon. If you do give us a review, it's always appreciated to learn what we can improve. So this was our part, but there's a lot that you can also do. So again, we really want to build a community that you also work together and work with us. So if you're a company, then please write us. host an event, we need locations, we need food, we need sponsors, or just become a sponsor in general to support us. If you're an individuum, then feel free to tell us what you're doing. If you can be a speaker, right? If you feel like you're not ready for a speaker, but you still want to support us, you can just become an official member. So that's also an option. Or just join the organizer team and help us organizing such events. So yeah, for locations, again, like we're very thankful that we have people and companies to support us here, provide locations like ESC now and EuroCC, but also we are typically at the Central European University and at We Accelerate. Those also support us very regularly. We have some mid-sized companies who sponsor us. That's also really very helpful. And regarding what you can also do if you're not ready to be a speaker, so we have revamped a little bit the membership structure now. So if you want to support us, there's a yearly fee of €39, but you currently get a €10 off. I think it's not. It's so the flat rate for students has the discount code student, and the first the €10 discount is actually first. So just enter that and you get €10 off for the first year. And actually, you're not only supporting us, that we can provide meetups and that we can host a website and have Slack and all other of those things. But you also get your own Google account and email address. You get a lot of benefits, a lot of discounts when it comes to conferences and courses. Also some online courses which you actually get for free. So you even get something back for that contribution. We're also planning some member internal events which are coming this year. So actually there will be a lot of things, a lot of benefits that you will get for that. Yeah, and with that, I think we're actually ready to start with the first speaker. So we'll kick off everything with Jakob Reiter, who is an entrepreneur, developer, and human digitalist. He's the founder of Mimiro, where he helps customers, so smaller companies and enterprise businesses, to deploy solutions with more privately focused AIs. So I hope I got everything right.
Sure. I'll set up in a second.
Yeah, let's just switch.
Okay. Stop. All right. So, can you hear me? Does the mic work? Otherwise, I'll just, yes, good. Always the mic check. Hello. Okay, cool. Hi. My name is Jacob. I come from a company called Mimiro. I'm a co-founder and CEO there. But I don't want to talk about my company. I want to talk about something that's actually more important to my heart, and that's AI sovereignty. And I'm in a little bit of a pickle. When I designed that talk in November, I had like a really interesting idea on how to present that topic, right? Because sovereignty is kind of like an abstract thing. It's hard to like say what it really is. Definitions changed over the centuries. So I said, well, you know, it would be funny to flip the concept on its head, right? To come up with a storyline that says maybe we can define the negative and then say what's missing. So I came up with this very elaborate story of a egomaniac dictator that rises to power in a democracy with the friends of their powerful business people with their own individual interests. And then all of that slips into fascism and totalitarianism, and I could explain the concept of sovereignty quite nice. But that's no longer funny. So I have to do the classical route of explaining what it is and how it works and how we might miss it in the future. So, sovereignty. Sovereignty is a really interesting term because it changed a lot over the centuries. Back in ancient Rome, the idea was that the individuals, the populace, transfer their authority to the emperor, And the emperor kind of like acts in their own interest and kind of like wields that amount of power absolute. Then it changed in the Middle Ages, which was really interesting because it changed to a feudal aristocrat system. So back in the Middle Ages, the king was not actually the sovereign, but the aristocrats were the sovereign, and they were transferring their authority to the king. Might sound familiar given the last picture. And then in Reformation times and Enlightenment times, it changed again with Thomas Hobbes, who's the guy who wrote the book on the topic, basically, who wrote in this Leviathan about today's concept of sovereignty. And what you see here, that's actually the sovereign. And I hope you can see it from the back. The sovereign is composed out of the individual people. That's the pattern on the shirt. So that makes the sovereign that's over the land and yields the power with the sword and the stick, basically. So sovereignty means then control, authority over something, over a land, over certain rights, over certain privileges. And AI sovereignty, as the term derives from there, then means the control authority over your AI system, meaning the training data, meaning the customization, meaning the grounding, meaning everything that goes around this. All right? So, should we talk about states? No, I think it's more interesting to talk about this in a business context. Because if you look at the business landscape, you probably see a lot of those companies, the Northern European, Silicon Valley, New York angle of like the known companies. And if you're coming or have connections to Southeast Asia, you're seeing a lot of those companies that are quite popular there with Alibaba and those kind of like. And then there's this middle ground, those European companies, and they're kind of hard to pin down. There's some notable AI companies, like Mostly AI here in Vienna, hello, Mistral in Paris, there is Aleph Alpha in Germany, but there's also like SAP, which is like the oldest company in the world probably, and Siemens, who are doing a lot of really exciting AI stuff, but basically go under the radar because they're not Gen AI and not young and cool. And then there's like Black Forest, like Flux, and those kind of companies that have like really niche products, right? Or this company, everyone seen this company before? They do they field proteins to like make molecules and stuff like this. They're one of the world leading companies. I have forgotten their name, right? But they're in Europe. So Europe has this weird mix of AI companies, but very, very specialized, very vertical, very niche, whereas most of the rest of the world, they have what I call horizontal, really broad applications. NVIDIA, Google, Amazon, Microsoft, OpenAI, all right? So why is sovereignty critical for business? Because we're in this pickle, again, between the US, China, and our vertical AI, where we really shine, but really reliant on those players in terms of horizontal AI. So how does this trickle down into a business effect? If you have a business, why would you care about it? Well, there's hidden influencers. What I mean with hidden influencers, that AI is not a blank canvas, right? It comes with a lot of backpack, and you have to be very careful what that actually is. So most of the time you can say there is a political view that is out there, we don't know which one, that goes into the data, selecting the right training data, selecting what is out there, goes into the training, goes into a model, and then ends up as your very friendly company AI. And suddenly you're faced with something that you talk to that is not blank, but potentially very politically biased. And we know that for sure because there is a lot of research on that topic already. So I put that in there. You can take a picture. That's very interesting research you can read. I picked some of the examples out of those research things. So here is a combination out of critical issues and the corresponding models. And in red, whether that model opposes that topic, or blue supports that topic. So if you have social media regulation on the very right, Llama 2 Chat 7b opposes it. But the 13 billion model supports it. So whether or not your company has to do with social media, you should be aware that choosing between the 7b and the 13b model gives you a different bias in how the model itself sees that topic. That's also here for death penalty, climate change. Thankfully, none of them opposes that topic. Public education, healthcare reform, etc., etc. So that's actually very critical. Imagine you are in one of those topics and you're getting an AI into your company that has an opposite view of what you actually do and want. Another thing is political spectrum, right? This is a very interesting study. For example, if you look at the Twitter Croc, which has a fun mode and a regular mode. If you are in regular mode, you're always up here under almost authoritarian left, politically wise. If you then switch to fun mode, you go all the way down here to almost liberal. So you basically change in terms of political spectrum, you change aisles in the American system, right? Or what is also interesting, Mistral, they're very left liberal. I mean, France, okay, makes sense. Their training data was quite culturally selected, right? So finding out the political spectrum of what you actually have gives you potentially a different view of where you go. There was a recent study where they asked about 1,200 names of people. Tell me about Edward Snowden. And then they analyzed where politically biased in that spectrum the answer would lie. And that drastically moves from model to model, right? So if your employees in a company rely on those kind of sourced information, they'll get biased over time into a certain direction, and you should be aware of where you're heading with this. Here's also a fun part. Llama Model 3 70B. You can ask it in English and German. You get different answers. Same model, just the input language is different. Stimmst du zu, urheberrechtlich geschützte Werke sollen in der EU für nicht kommerzielle Zwecke kostenlos verwendet werden dürfen? No. If you ask the exact same question in English, you get a yes. So there's also a little bit of schizophrenia in this model, because the bias is not regular. It depends on which language, input language, that corresponds to. Last but not least, DeepSeek. Let the hype train go off. Obviously, we have all been on social media the last couple of days. It censors itself. It's very strictly on party line. There's some really interesting things going on under the hood that is pre-trained, that in that architecture there's some really interesting things deeply embedded. So the status of Taiwan always gives you the exact answer, no token generation. So it's on party line. Great, right? Happy to deploy DeepSeeker in my organization. So we must ask ourselves as a community, is there a cultural fit between my model and the company? Am I deploying the right model to what fits me as a company and where I stand with my core values? Second, the efficiency trap. So what happens if intelligence eats everything? So normally a company exists somewhere in that space. A company has people, has processes, has machines, and has data. And depending on which field you are, you get a different mix. The green one, for example, here would be a service company, right? Lots of people that work in consulting and a lot of data, but barely any hardware, machines, and some processes, but not a lot, right? Whereas the blue one would probably be more like an industry example where there's lots of machines and lots of people, but the data collected is mediocre and the processes are very strictly defined. So you get something like this. But what happens now if intelligence becomes a commodity and is available everywhere? Well, you start to put the people into the AI. You start to put the processes into the AI. You put the data into the AI, and the machines basically becomes the AI. And then the question is, what is left of your company? what makes the company if everything is in the AI, and if that AI is OpenAI. Think of a producing company that lives off the process on how to do certain things in research. What if that's given to AI? What's left of that company? So it becomes critical in that efficiency trap. We want to give everything better to also control what happens with that angle. And we must bring that back into the company, and that's where we talk again about AI sovereignty, where we bring that AI under the control of the company and allow that to foster and flourish within the company, because then the company can retain its identity in that crazy race we're in. And that's where AI sovereignty is a big thing. So we must ask ourselves, what is left of a company if intelligence is commoditized? And that's the world we live in. Intelligence is no longer a bottleneck. It's available everywhere for really cheap money. Last but not least, there's no MBA for an LLM. Or why LLM is the spark and not the fire. So the problem is the LLM has a gigantic knowledge. But the thing that actually counts is that little information here of your company information that's not in the LLM. Ask ChatGPT about your last meeting you had of the day. It will not give you the answer because it's not in the multi-layer perceptron, right? It's not saved anywhere. So with that gap, it's most often pretty useless for companies to use ChatGPT. Yes, you can upload a lot of documents and then get a summary, but think about it. You need to know what's in the document so you know what documents to upload to then get a summary. That's not a really good use case, right? So why not fine-tune a model? Here are 8 wonderful reasons why not to use it. Because you might for sure overfit it. It is very resource intensive, except if you are a high-performance computer center. You need a lot of really high-quality data that you probably not have and probably not have cycled for. You might end up with a catastrophic forgetting because you suddenly erase everything you've already trained on before. And yada, yada, yada. Most likely, you're even adding some biases and ethical concerns through your own data that is not properly checked. Alternatives? Well, you can start with a RAG system, right? A RAG system is a very clever idea. You have a database with knowledge, and then you use, based on that prompt, a search in that vector space. You add it to the document jumps. You copy-paste it into the LLM. Here you go, right? The problem is that works only in a very narrow domain. That does not work if you load your entire company data into the vector space. Good luck with that. So let's make it better. Let's have a graph database added on top of it, because then we can start to manage different dependencies and start to understand the objects in there. That becomes cool, but that has barely reached production-ready levelness. So you're here almost on the brink of research. This is right out of the lab. There are some narrow cases that are being deployed, but scaling this is already hard. But it will not give you fully the good answer because you're talking terabytes of data. So you come up with an even better system. You start to use an agentic system where you have an agent that does the querying and re-improving, and then you add a feedback loop to it so it improves continuously before it gives you an answer. Now you're super into research. Now this is lab status, and no one has really successfully scaled that. But it is nevertheless super, super interesting because, first of all, it remains an unsolved problem for production readiness in medium to large scale environments. And it's absolutely crucial to derive reliable and grounded answers for your AI system. Because the RAG system allows you to run on a CPU. You're independent of the GPU race and the horrendous ransomware that NVIDIA is requesting from you by now. You can add stuff fast and easy in the RAG system. You don't have to fine-tune it for hours. You can basically just add it, and then here we go. And the knowledge management can be super local and the LLM can be somewhere in the cloud, and you can deploy like a hybrid approach that is really interesting in terms of resource efficiencies. So Europe possesses a wealth of niche and specialized knowledge. So can this be the answer to the question, where is Europe heading and what could be a potential way forward in Europe? And we must ask ourselves, we are losing the battle about intelligence, but is AI knowledge management a way forward for Europe? And this is where we at the Venturi in my company, we say strongly yes. And this is also what we're building. We're building a private, sovereign, and agentic AI management system that allows you to run everything locally, run everything privately in your own environment, and then also combine this with an autonomous AI capability. So you can do some fun stuff with our software where the agent goes into the CRM, goes into your emails, goes into your files, collects all the information you need, processes it, and then submits a form, writes an email, or even goes out autonomously and executes on your behalf. And this could be very interesting, and this is also how I would propose Europe positions itself, as not with the intelligent part and the LLM training, but really harnessing what we have as a knowledge provider, as a diversity provider, and provide that counterpart that is needed to ground AI in reality through our specialized knowledge. So I'm open for discussion. I might or might not have the answer. But I invite everyone to be part of that discussion and think about how your organization can be sovereign and how we can find a niche for Europe, because otherwise we'll become a natural resource for the US and they'll extract data out of us, but we have barely any role in that game to come. Thank you.
Okay. So with that, we will continue with the second speaker. So it's Markus Stör, who is the head of the Austrian Competence Center for High Performance Computation. He has 20 years of experience in that field, and is helping SMEs and startups to utilize infrastructure that is at hands, publicly available. So he can show you some really cool stuff, what you already can use by yourself when it comes to compute power. So enjoy.
So hello. So is the mic now loud enough? Okay. So welcome everybody here at Arsenal. My name is Markus Stör, and today we're talking a little bit about what we're doing here. So here in this building, our supercomputers are located, which we will look at later. And yeah, I will tell you a little bit about what we are doing and what possibilities maybe there might be also for you out there, since we are publicly funded and also connected to the university ecosystem. So there's might be some interesting things for you to look at. I've heard that it might be a little bit far outside here. I know this Arsenal is a little bit far to go, but just to tell you, it's not always as easy to reach data centers as in our case. For example, in Norway, there is a huge data center built right into a mining complex. So the traveling there might be even more painful. So thank you for coming here. So my two roles are just shown here to know what we are talking about. On the one hand, it's the Vienna Scientific Cluster. These are the machines that we'll look at later. This is basically run by the universities here in Austria and funded by the ministries. And we're mainly talking to the academia and teaching them and helping them to use these supercomputers and provide the resources for all the researchers in Austria mainly. EuroCC Austria is a project which is partially EU funded, and we are doing a so-called National Competence Center for Supercomputing, Big Data and Artificial Intelligence. This is the part where we're talking also to startups, SMEs, companies, and help them to make use of these technologies. And depending on where you're coming from, the message is we are happy to talk to anyone, tell what we do and help them doing steps and improve on their skills in these areas. But what exactly is HPC and how has it evolved over the years? So HPC is as the other term for supercomputing, which is usually called high performance computing. And here we have on the slides we have some things which have changed over the last decades. So when I started, I'm like 2005 time ago. So we had the computing power was much less. The things that you were able to calculate were much smaller. And with the huge increase in the processing power and the number of hardware available, also the problem size you can solve and so on increased over the time. Especially when you then look at now the introduction of GPUs, which brought an enormous improvement in computing power, which led to even more capabilities that you have concerning doing simulations and data manipulation and so on. On the other hand, when you look at the scientific domains which are using these kind of methods in former times, like last century, usually physics, engineering were the main users of such technologies for doing CFD, so fluid dynamic simulations, finite element simulations, something like that, or classical physics, different scopes. So these were the main users, and over the time, these simulation technologies have been used now by more and more scientific domains and have gained more and more users. It went from, as said before, then via bioinformatics, different other biological applications, and then data science, and now with the beginning of this artificial intelligence, basically to all scientific domains. The users that we are seeing on our machines, mainly from the academia, but can be from any scientific domain, even let's say people doing politics or language studies and so on. So this is a wide field, and the use of such technology is very widely now. And yeah, that's basically that. And the last point that now comes in is this huge availability of data and the ever-growing amounts of data that you can analyze and use for your things. So this is another part which is also important to have an eye on. So when we now think about what is then actually supercomputing, we have asked ChatGPT, of course. So this is one of a reference to this already available models. I might talk a little bit about other models later on, but the answer is given here. So it's like a Formula One car for computation. So you might not need it any time, but sometimes for special things you might use it. And that's basically how you can see it. So there are special applications, and for researchers, for certain things they need it, and they do a lot of computations, and when they're done, they have the results and can work on that and continue with that. In the AI context, this would be, for example, doing a fine-tuning or training of a model. And then when you have done it, you can go with the results and come back later in 1 year or whatsoever. From a conceptual point of view, supercomputing is basically putting together a lot of hardware. So you can build a computing cluster also out of Raspberry Pi. So this is what we have built over there. This is our demo cluster. But basically, you put together a lot of servers and connect it via a strong network, use proper software to have available distributed computing, and then you can do really simulations instead of one server on a lot of server and scale to really big problems or reduce computing time significantly. So this is the idea behind that. Get your solution faster done, or or be able to calculate much larger problems than before. With all that together, also storage is always an important point. Depending on what you're doing, if you're relying on storage access heavily, so also the connection of the storage to your computing power is important, because if you cannot access the data fast enough, your computation will basically have to wait to get the data and to continue. We have some our systems I will explain later on a little bit, but we have our latest system is ranked 50, so 50 in a ranked list of supercomputers mainly in academia, and it's not so bad. So we're happy to have that. But if you go to the first places, the increase in computing power is obviously not linear, but more like much more steeper. So there's much room to improve, but we're happy to have some resources here in Austria that we can use for decent research and simulations. When we look at now the areas where we can use these simulation power, so the classical thing is what you can say is simulation. So it would be like what I did when I was a researcher. I come from computational material science, so doing simulations about how metals and different things look like. So you can do really simulations based just on quantum mechanics and simulate different properties and use HPC technology to get your results, and then compare to experiments and see what's going on. Modeling is the other classical thing, which is for doing fluid dynamic simulations, finite element simulations to get stability or structural stability of buildings, for example, something like that. Complex problems can be solved with that. The new thing since a few years, very important, artificial intelligence, machine learning. So there's also research going on in all kinds of, let's say, in the technical field, physics, informatics, things. These guys are also looking in that and using machine learning to speed up or to increase the efficiency of their codes, and also be able to handle more efficient the data that they have and so on. Data analytics is obviously having a lot of data. I would say it goes into the direction of what Jakob is doing. We have data, and you have to want to work with that and get knowledge of that. Not directly with company data, but could be any kind of data. The question is now, I would like to do a short survey. So do you think, is there anything in our life which is not connected to high performance computing or simulation nowadays? So so there are 3 pictures, and the question is there anything? Do you think all of them? Is there something on this picture which has nothing to do with HPC? Are there any ideas? The Pringles. So you think the Pringles have nothing to do with HPC, but what about these others? So this the plane could be maybe. And what about this drugs? So drugs and so on. You think this has to do with HPC? Okay. So let's see. I can try to elaborate a little bit on that. Actually, okay, plane, you're right, obviously. So there are a lot of simulations. I've mentioned before the word fluid dynamic simulations for optimizing the shape of the geometry, and so on. So that's very clear, done since a lot of time, since a long time. The other thing is drug design. So this is especially it's interesting also to mention that drug design has drug design is an important thing nowadays, and we have the example given here shows you just how long it took to decode the genome of different viruses, and you can see for the HIV virus it took nearly 30 years to find out how this genome looks like, and with increasing time with increasing in the time, the time to decode the genome always decreased. This is also due to the huge amount of computing power available and how to handle sequencing data in biology. So this there's now a significant speed up in these technology fields, and high performance computing is a very important part on that. During the COVID pandemics, there were also some special allocations also on our supercomputers and also on the European supercomputers. If you would have had a research project on COVID, they would have give you fast lane access to help work on these problems. So now concerning the chips. So I must say at least this brand here is HPC influenced. So they did some research and simulations, so that in order to have a shape which is surviving transport and not to be destroyed when it comes to heavy shaking, for example, and also that when in the production that it's floating down nicely. So they really did, it's like 20 years ago at least, as far as to my knowledge, but they did simulations to find out and find the optimal shape for their product. So yeah, so it was kind of a trick question, but interesting to see that even there's some computing power involved. Yeah, so. Now a little bit some hints about data, which is also important to handle. So as I mentioned before, we have this exponential growth of data, and there are some points that we can look at what are important when working with a lot of data. So at our clusters, the storage systems, we're talking usually of terabyte or petabyte of data. Especially depending on what kind of research you're doing. Nowadays, terabytes of data are standard, I would say. So for us, handling large amounts of data is normal, and we have always an eye of or an idea of what has to be looked at when doing simulations, especially with accessing a lot of data. First of all, we have to think about how to store the data, and usually for really big use cases, I would say we're going, when it starts going in the hundreds of gigabytes, but also there might be interesting things to look at which when you have only a few gigabytes. And I just put down some names so that you know what we are using here on our systems, which is usually the GPFS or IBM Spectrum Scale file system, which is mainly commonly used by a lot of companies, and you have also some other other file systems for very fast access also in place, so that you have, if you have heavy simulations with which need very fast access in short times, you can transfer your data on this so-called Weka storage. It's also it's a different solution. Yeah? The thing that you have to keep then in mind when working with the data is how to access it. So I put down some access patterns, but basically the thing is, you have, if you do a simulation, you have the problem, if you want to scale it, how do I do it? So I can, on the one hand, have a lot of servers which you work on the same data, This could be on speed up. The other thing is I would have a lot of servers which work on parts of the data, and you can have different combinations on that. So this is just, there are a lot of patterns out there, and the point is here just to tell you, you have to know what's happening, and there's always a good solution, and there's might be some tricks to go on, to look into, but there's sometimes significant speed up just to know how to do it right. So if you're stuck, there might be also, I will mention that later, trainings or things to look into that can help you to how to work on such problems and which things are to consider. Then there's sometimes things going on which rely on real-time access, access to computing power. This is usually not a problem, but for example, if you're a weather provider, where you have to do your calculation in a short time. So if, for example, you get the latest weather station data at 10 o'clock, and the weather forecast has to be ready at 2 o'clock, you need basically a complete supercomputer to do the run. And this means you either have to shut down, so depending on how the model is, so the access model is, you have your supercomputer waiting all the time and then start the run at the appropriate time. But if you want to run other jobs in the meantime, it must be clear that these jobs are purged from the queue to make the system available. So this is just a basically consideration how to process data depending on the time requirements. So if you don't have time requirements, you don't have to care. It's just a very basic thing. This is just an overview, and there are a lot of numbers here written down. If we will have the slide in the end again, it's just to to tell you that we have currently three systems running, and we will all look at them later. And VST4 is the oldest system, which is only a CPU, has only CPU nodes, so servers with CPU on it. VST5 is a few years younger. There you can see that we have already about 10% of the compute nodes with GPUs attached, and the new Musica system, the latest one, has basically a large overhead on GPU nodes, since it is built mainly also for AI application, but also should be meant to be able to host or to run GPU accelerated normal simulations. Yeah? So you can see here in the history of the purchase of the clusters that the GPU topic is also now in research important. Yeah? Concerning the power consumption, you can see the numbers are maybe in the back a little bit small. The former systems had like 450 kilowatt to 500 kilowatts power consumption. In the Musica system, even it's much less space, it uses about 1 megawatt as it is installed right now in what you will see today. There's also a European perspective. So the message is there are supercomputers which are can be accessed for testing purposes, developing purposes, also for doing simulations by anyone in the EU. You can look at their open calls, you can look at what's going on, and you can get access and try out things. We can assist here, and everybody who is interested can work on these supercomputers. You can see where they are currently located. The other thing which is mentioned here is this AI factory thing. This is basically supercomputers, still much more optimized for the AI topic. This goes into the direction what Jakob told us before. So the EU wants really to at least to try, or really wants to go into this AI. Okay, let's call it sovereignty. So to have hardware and capabilities here that people can train and work on the problems in Europe. And the goal is besides having these supercomputers that you have here, that also have GPUs inside, build even more AI capable systems than before, and concentrate hardware on locations to enable especially SMEs, but also researchers to work on these machines. And also these AI factories will have a component which is very service orientated, so everybody can in theory go there and ask for help with their AI problems, really on proof of concept basis or project basis to see how to get things done. Yeah? So this is things which open to all companies. Yes, we'll have contact points later, as said before. I've mentioned it a few times before, so we're always happy to talk to anybody. We can help you to get things done. And there's also, this is now in the slide, so we have, we can help you with consulting, so we can help you with talking about your problem, identify your problem, see what's going on. But there are also a lot of training courses going on different topics in supercomputing, but also on different AI and machine learning topics. So Claudia, my colleague in the background, who will also do some guided tour today, is organizing and giving a lot of courses herself. And as said, we have the infrastructure available. So this is again, this is now the hint. So we have a list of courses which can be looked at on our VSC homepage, and also at EuroCC Austria, there's the general contact point for anyone who needs help. Also, companies, SME startups, we are happy to talk to you. Yes, and just as you can see here on the topic list, the hot thing is LLMs, GPUs, and AI topics, obviously, nowadays. And so if you're interested, you can easily join the courses. They are mostly online or sometimes in hybrid mode, so it's easy to look into. Yeah? There are we have some examples. So basically just two. There's one company that we've worked with from Italy actually, and this is a startup which is working in the nuclear industry. So basically in the field of when it comes about procurement and looking how to build an atomic power plant, and their thing is. Similar thing like Jakob is doing. Basically, they're building also an LLM RAG-based system partially to look at all the documents and all the regulations which are around the topic of building power plants, and they want to basically build advisors to help people who are in charge of that or want to write a project proposal to have everything in view and not to forget anything. And there's also for them it's very important to have very low failure probability, because it's a very important topic, and they have the topic trustworthiness is important. So the data quality of the input data is important, and so on. And okay, they have let's say they have a complicated setup. But it all boils down to working with to fine-tune or pre-train some smaller large language models. And what they have done this on our Vienna Scientific Cluster 5 machine. And the most important thing is that the pro point for doing that was they can use existing infrastructure and they don't have to build it themselves. So they could just use what was around, do their simulations and go away. And they said, okay, it's an estimated number, but it's a huge amount of a few €100,000, which they didn't have to invest to build their own servers and just have it for a certain amount of time. And since the environment was there, and they could fast simulations, the model development which they did was much faster than expected. And this results obviously faster time to market, so they expect now having the product ready somewhere in this year. So that's for example what we see and what is happening. The other thing that we have done recently is this an FFG project called Hybris, and there we looked into our part was just looking into fine tuning and how to scale it. So we looked at some standard models. So for example, a llama model, and we used a defined data set on how to and try to do a fine tuning on that basically. Yeah? And so and the question is now when you first did the fine tuning, it was basically on one GPU, so on one server, and the time was like 224 hours. And the question is, what would you do in this amount of time? So imagine you would have computational task that you would have like 10 days for it. What would you do? What? Oh, boy, that's a tough one. Yeah, so you have a lot of time to spend to get your results, and you could you could play solitaire, but you also could go for a holiday, for example. Yeah. What we then did is my colleagues put into some distributed data parallelism, and so that the model was trained on more GPUs on several servers, and the training time for the same data set with the same quality dropped down to somehow below 4 hours. So this is still a decent amount of time, and you can do something in between. So maybe go to a cinema, theater, or something like that. Still some amount of time, and then they used even more interesting libraries, and this then broke down even to below 1 hour. So that's kind of a lunch break. Yeah? So the message here is there is some expertise around, and we have computing power to look into such things. If there are problems, the speed up can be significantly. So that the waiting time basically dropped a factor more than 200 in that case. Yeah? Now I just have 1 or 2 slides about what you're going to see, just a concept thing, and then I'm done. So we don't have detailed photos of what we will show later on. So just to give you a concept how a supercomputer look like, and they will mention things that you will see, but it's basically just racks with hardware inside. And we can tell you then when we do the guided tour how it looks like. So the access is always from the outside to so-called login nodes or other interfaces. This secure shell access is the classical one, but there are also more web-based access possibilities like Jupyter Hub or even VNC session-like access things where you have a graphical window manager visible. And as said, the one important component is the storage. So you will see racks stuffed with servers where just a lot of disks are inside. And we have a lot of compute nodes. This is what you will see, which is mostly very hot, usually, which is because it produces a lot of heat. And in between, you will see a lot of network cabling. So there's a significant amount also in REST for such computers for the network part, because we have Ethernet as a usual network Ethernet available, but for transporting a lot of data and communication patterns in a short time, you need a fast network, which is usually InfiniBand in our case nowadays. And to be complete for the operation, you usually do not access these compute nodes directly, but over a scheduling system. So you basically write bash scripts on the command line that are submitted to the scheduler, and it dispatches the jobs as where free resources are, basically. Yeah? As said before, we will show you the different machines. So I think what the order is now, I have to remember. We first go to VSC4, then VSC5, then we will go to Musica, and afterwards we will just show you a quick glance on on our piping room, just a look in. So one important thing about all this supercomputer is, since you see there's some energy involved, is cooling. So especially in summer, if there's some issue with the cooling, we always have to be careful to shut down the things. The difference to normal data centers is that the power density is much more. So per rack we are like 30, 40 kilowatts. In usual data centers you have like 10 kilowatts only. So it's much more dense. And so we have to be a little bit careful about that. So cooling is always an issue. Okay, so I hope I was on time. Yeah. And yeah, thank you. If there are any questions.